Hi, this is Christian at NeverEngine Labs, and this video is part of the Rhythmic Computation Lab 2018. It's another step-by-step tutorial around focusing on the complex sequencer I've designed called the NeverEngine Labs Global Sequencer for Kyma 7. We're calling it GlobSeq for short, and I think we're just going to go through in this video a real sort of starting from scratch situation so that we can begin to take a look at how to program it and how quickly you can build up complex sequences. Now, although this script and text might seem a little daunting at first, it really is quite straightforward as far as scripting goes, and it's simply a case of understanding programmatic syntax. In the GlobSeq, we use all of Kyma's built-in Capitalk and Smalltalk abilities, but I've extended it with a special set of commands, or these hash symbols that are specifically being interpreted as commands for the GlobSeq. They do things like fills and glides and other MIDI controller data and special loop modes. Everything's broken down in the quick start manual and inside the Kyma parameter descriptions, the inline help. So let's get started just from scratch, building something up and see how that goes. So this is the Kym that is in the shared folders you have on your desktop of the Rhythmic Computation Lab, and you'll see that it is here, the latest GlobSeq version 3.b23 beta testing. Now let's start there. So if you open it, it already comes with a bunch of scripts which I put in there just as a starting point for you to get familiar with the way this sequencer works. But I think for this video we're going to just delete them all and start from scratch. Sometimes that's good to see how it goes. Now, the gates row is the first row that you're going to define because it's an important one. It's like a kind of global or master pattern of switches that will say when the sequencer steps forward, whether it will read the next value from all of the rows that you're going to define. So it's an on and off type of row, but the elements don't necessarily have to be on and off, as we'll see a little bit later. But if they are off, if the value is 0, then when the sequencer steps, it will not read the next value from each row. So this is already the beginnings of the complexity of this sequencer. So the main point to remember is that the gates row, the stages, is a compulsory field because it defines the master length of this particular instance of the global sequencer. Quickly going back to the manual, we see that there is a certain basic syntax that is required to define each row, each of these rows of pitch or gates or generated patterns, and that is, I've written it many times, so hopefully you will really remember this, is that the first element to define a pattern first element in the row is the name that will be broadcast, right? The global event. It's the name of the global event. And what does that really mean? It means that when a row is defined as values, the step sequencer will step through those values, and then one parameter, one hot value, the one that we're going to name first, will take on each value as it steps through. Kind of makes sense, right? You need to, it's the output if you want to think of it that way. So the first thing we define in the gates row is a name for that generated value. Sometimes I like to just put something like gen in front to remind me that it's being generated, like gen gate, okay? And then we can simply manually put in 1, 2, 3, 4, 5, 6, 7, 8, a rhythm, if you like, a rhythm of the gate is on, and the gate is off, and the gate is off, then it's on, then it's off, then it's off, then it's on, then it's on, and it's a row of 8 elements. Then, as this is this version of the GlobSeq version 3b2223 outputs MIDI. Then to output MIDI, we need some kind of MIDI notes. So this is to use the sequencer to output notes to MIDI, or in general, that's why you have a pitches row. And again, the same thing applies. The first element will be the pitch, but it's going to be like a generated pitch, so I'll put gen to remind myself. And then we can just put a row of values. I'm going to use note numbers here. Just go up in some kind of steps up through a scale. Pretty arbitrary. Now the important thing to note here as well is that you don't have to put 8 pitches in, even though the master row has 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. But for now, we're going to put 8 in, because I want to demonstrate how the gate and the pitch interacts. So let's just try and run this. I'm going to just going to press play, and okay, so these are the events that have been generated. You can see this one, the VCS algorithm will just throw it somewhere. If you expand it, you'll see it's called gen gate, and it's going on and off. Here's the gen pitch that was generated. It's global values. So you can see it's reading. These are just some kind of presets that were stored before. But you can see that the gen gate, if we change that widget to, for example, a button, you can see it's flashing on and off, and the pitch is being read from the row. I'm just trying to find the numbers. Yeah, it's a fader. Okay, let's get the number nice and big. Yeah, all right, good. You can see that the pitches are being read, as we might expect. Now you see that it's missing some steps here. Now the reason is because in GlobSeq, the gate, if the gate is on, then the value from the row at that stage, the first stage in this case, will be read, 40. The next stage or step is counting from 0, so this is step 1 here. This is, or stage or step, I'm not sure which word you prefer to use, but it's like this stage 0, which is the first stage, is read, 40 is read from the pitch row. But as the next stage is off, 43 is not read in my sequencer. It's 40 is held until the next stage is on. And in this case, the next stage relates to this value, 48. So it will hold 40, and then 48 will occur. And then there's another hold of 48 over these two elements, and then the last two are red, so 58 and 60. So you'll see that's what we're getting here. Getting a rhythm pattern where a kind of masking effect of the sequencer is already inherent there. Now, before we go into the rest, into hot values and things like that, I'm just going to introduce already the extra syntax that I've added. Now, one is called loop. And as we've seen here in the manual, which you can open up and have there, loop is a kind of loop mode for each individual row that you're going to define. It can be different for every row. So this is actually wrong in the manual. It's I'll have to correct that. It's 0 is forwards, 1 is ping pong, and 2 is chaotic. So if you put sorry, it's going to do ping pong. You can see it there. This is a visualization of the stage that it's on. Yeah, so similarly, if we loop with a 2, which is the actually it's chaotic. I will correct the manual. It's a little bit confusing starting from 0. Chaotic, we see we're jumping around here chaotically, the stages. Yet the pitch is reading forwards. The pitch is not jumping around chaotically, but it is stepping forwards, but only when the gate happens to land on a positive stage. So that's already another quite a nice level of complexity. Of course, you might want to do this stuff on the fly. So each of these optional values can be a hot value. So you can make a switch, or let's call it something like gates loop mode. So I'll get a new fader somewhere here. I already seem to have defined it to be the right type of widget, but you might see it as a fader. But the point is that this is a radio buttons widget, you see, and it's got some labels. By the way, you can label this yourself correctly. So the first value is 0, is forward, 1 is ping pong, 2 is chaotic, right? You see? Okay, so now you can do that. And chaotic. You can switch modes on the fly. The other useful custom parameter unique to the GlobSeq is a clock divider, which is #div. If you divide by 1, then you get 1 step every pulse, which is what we might be expecting. It's the fastest rate of the clock. If we divide by 2, it needs 2 pulses in order to step, and divide by 4, so on. You can quickly make that a hot value, so you can change it on the fly. So clock divide. Let's say this. It should appear in the VCS somewhere. Yeah, here it does. It's just appeared as the generic small fader, generic fader with from 0 to 1, but we want to have it as a something like this, a fader with 8 integer steps. Let's say we want to have some tick marks. Great, let's hide the number. Now we've got a way to divide the master pattern independently of the gen pitch pattern, which is something we can see is already bringing quite a lot of complexity, just these two. So one thing I am encouraging all the way through the labs is to tidy up your scripts with Alt and Tab. Because Kyma doesn't mind if there's spaces and returns and things, you can just Alt and Tab to put some indents in, and it helps to make it more legible. But what I want to show you now, just example here, is how quick this can start to do really interesting stuff. So we're now going to just create a couple more faders, the pitches loop mode and the pitches loop. And type that properly. The pitches clock divider. So that means that the master pattern and the pitch pattern you'll be able to loop them and divide them independently. So again, VCS creates some generic faders for those two values that we've just specified. Again, this one is like this one. It's radio buttons. It's going from 0 to 2, the steps of 1. There we go. This one is this clock divider idea again, so it's going to be 1 to whatever you prefer. Maybe you want to make it in grids of 2, so it's always a metric even division. And maybe you want to have some tick marks and labels. Let me do that again, just realized it was hanging off the screen. Set tick marks and labels. Yeah, how much is numeric? Yes, okay. Oh, it's only odd. Odd divisions. But you can see how the pitch is holding its value because it's stepping. It needs a. How can we make that even? It's like that. Yeah. It needs 4 steps before it will change, whereas the clock divider is going every step, and maybe it can go every 2 or every 3. So you can start to create some quite complex patterns this way. Perhaps the pitch loop mode can be chaotic. It's going to choose a different one from your set of values here. So I think for now that could be just enough to look at and for you to try out. But as a final thing, I just want to show you how the first thing you're going to want to do is to have a way to turn those stages on and off with a button, or have these as values that you can change in the VCS. So that's where we're going to use some Smalltalk to define those rows. But just to show you the long way round of doing it, that would be, okay, 8 steps. I need to define 8 widgets. So I would have to type something like gate 0, 0, gate 0, 1, gate 0, 2, gate 0, 3, so on. I'm already getting a bit tired actually. I could do a really tricky cut and paste thing. But this is, you see what I'm trying to do? I'm trying to define 8 different widgets that will be something some stages I can turn on and off. And see how I've already defined, I did 4, so they've appeared over here somewhere. and one here and one there. So, you know, that's a start, but it's a real drag typing that. So exactly the same thing done in Smalltalk. You know, save yourself a lot of typing. Let's just do it. Put it in curly parenthesis. I'm going to create 8 of them. I'm going to make a collection of 8 of these objects, because that's what that, you know, what I was typing a second ago, that was a collection of elements, right, or objects. So I'm going to collect them. I need to do a collection, you have to iterate through a block of code, and in that block I want to pass the value of whatever iteration it is, right? So I'll just use I as a variable. It can be any name you want, any name you want. Okay, it's just a variable. And then we will think about the pattern that I was typing. You know, if you think about what I was typing earlier, I was typing something like gate 01, gate 02. You know, it's a pattern. You can see it. It's always got the gate part is the same, but the number is incrementing, right? So there's a pattern there. So how can we define that? We just say, well, every iteration, the gate part stays consistent. But then as a suffix, we're going to add, iteration is too long, so we got I. We're going to add the iteration. And now suffix is a Capitalk command. You can look it up. Suffix 2 is also a Capitalk message. You can look that up. Suffix 2 does some padding. You know, the padding is where I just want it to be, instead of gate 1, I want it to be gate 01. This is useful for organizing widgets and stuff. You know, I want it to be gate 01, gate 02. So luckily we've got a simple way to do that, which is just to send this message. So we want gate to receive the message suffix 2, and then the suffix with a padding of 2 digits is going to be whatever iteration that is. Then we close the square block, because that's the only necessary code. There's nothing at the moment that we need to define, and it's done. Here we are. We now have 8 gate widgets, gate and the number. So I've defined this row really simply with, I don't have to type very much. As I was trying to demonstrate in the PDFs that I posted last update, if you highlight this little script and press Apple Y evaluate, you will see what it's generating. It's generating this Capitalk, which is a very simple collection of gates. You know, what's really neat is now you want to start getting into some really crazy complex stuff. Just turn up 32. You know, we've got 32 gates. Save yourself a lot of time typing. Yeah. So very powerful. Smalltalk. Just syntax. What happens if? Don't be afraid of syntax errors. What happens if there's no curlies? The interpreter is already telling you it's weird because it's going black, and we don't really know what's happening. If you try to run this, we might get a totally weird arbitrary error. That's essentially a syntax error. You haven't done the syntax right. Don't worry about this stuff. It's just Kyma's getting a little bit confused now. The only thing that's wrong is that you didn't put curly brackets around this whole constructing expression. So soon you get used to that, you know, and you can see everything is fine now. Oh no, it's not. There's some sometimes with errors in Kyma, some extra parentheses get added by the interpreter as it tries to take a guess at what it should have looked like, you know, and sometimes they can cause further syntax errors. That's just something to look out for. Finally, I'll show you how to sort out your VCS. You see how the gates are all over the place? So just collect them all up by dragging Shift and click, as in other editing environments. Shift and click helps you select the group. And here's a neat trick. You can just highlight them all, press Apple X to cut them. Then in the layout menu, add a new layout, rename it to VCS Designer or something like that. Paste all those widgets. They just come in where they were. And then you could do this neat trick, which is to, let's keep those, yes. Let's say from the cogwheel, automatically resize widgets when window size changes. That's pretty neat. So you can use the actual VCS window to resize them all. And then you could say clean up. Yeah, there's 8 of them, so 8 in a row. There we are. Now I can turn that resizing off. Open the window. They stay put. And in this GUI editor, VCS editor, we can now turn them all into switches, which might be toggle switches, which might be there. And you can also make them be green when they're on. Now you might want to resize them. Okay, and then I can select them all, copy, go to the top layer. When I paste them, they'll appear. Try and move them all at the same time, and not that one. Shift and click. Okay, rearrange things a bit. So now I've got a basic step sequencer. Well, not basic, it's quite complex already. We're not hearing anything simply for the sake of this video, so you can hear my words, but you might want to hear that before we go, so let's do it. Let's take an audible metronome, add it into the Kyma signal flow. Audible metronome needs a trigger, so let's use our generated event, gen gate, to be the trigger. Here it is. So now the trigger is going to be gen gate, and the pitches are here. They're in note number, so we could rather arbitrarily take this global event that's being generated for the pitches, and let's say it's going to be a kind of duration, like milliseconds. Why not? Let's see what happens. Okay, that's just the beginning, and thanks for watching. I hope it's been useful. See you soon.